Morning, Jaden. How you doing? Are we still going to have our three streams next week? Yes, Jaden. The plan is to still have our three streams next week. Um, After next week, it's going to change a little bit. So this next week will be the last weeks where we'll do the three streams. And good. Glad you're doing well. You get any Dunkin' Donuts this morning? Any donuts or coffee or anything? What have you done so far? No, I just had 5 eggs and wow, 5 A's. Man, that's been hungry, Jaden. And a biscuit and a cup of milk and coffee. Wow, sounds like a hearty breakfast. How do you like your eggs? Do you scramble them? Do you make a sandwich? Do you sunny side up them? How do you usually do that? Make omelets? What do you do? My favorite sunny side up with some toast. Make some toast on the side and dip it into the yolk. Ooh, that's my favorite. I eat them anyway besides sunny side up. Okay, so you're like the opposite of me. I prefer only to eat eggs sunny side up, but I'll eat them any other way as long as they have hot sauce. I can pretty much eat anything if it has hot sauce. Like scrambled, I don't love because I don't like the texture very much. But if I get some sauce on it, I'm happy. It's funny though you don't like them sunny side up. Questions 2 and 8 on the first page. No problem. Okay, so let's start with 2. Okay. So we have to solve, we're solving each equation. So we have 4t minus 3 divided by 5 is equal, minus 4 minus 2t divided by 3 equals 1. All right, so you're left with this. First things first, this isn't an inequality, so we're not going to do that whole process of the inequality. We're going to do a part of that, though, and that's the second step. So we do have to still do the second step, and the second step is to solve for the equation. First part of solving any equation with fractions is we want to get rid of the fractions. That's got to be our goal. Specifically, get rid of the fractions because we need to isolate the variables, and the variables are in the numerator. So we got to somehow get rid of these fractions so the variables can be solved for. To do that, we want to get a common denominator. So the common denominator between 5, 3, and 1 is 5 times 3, which is 15. So I'm going to have 15 as each of my denominators. Okay, now what we want to do is see how do I get from 5 to 15? Well, I multiply by 3. 5 times 3 is 15, so I have to multiply the numerator by 3 as well. So 3 times 4t minus 3. How do I get from 3 to 15? I multiply by 5. So I'll have 5 times 4 minus 2t. And then the fraction 1, when it's divided by 15, will just be 15 over 15. So I can drop the denominator since I have common denominators now. And I'm left with this equation. All right, now I'm going to distribute and then solve. So I'm going to distribute the 3. So I get 3 times 4 is 12t minus 9 minus 20 plus 10t equals 15. So remember, for this negative, that's a negative 5. So you have to distribute negative 5 to 4 and negative 2t. And then combine like terms, so 22t. Negative 9 minus 20 is negative 29 equals 15. Add 29. And you get 43, I believe, or 44. 44, sorry. 44 divided by 22, t equals 2. And that's it. And that is your answer for 2. So go ahead, Jade, let me know how was that for you. It's really hot in my loft up in my apartment, and it's killing me right now. I'm sweating like crazy. I gotta turn on the air conditioning. I'm curious if you got that wrong. I got it right, but I thought I did. Oh, okay. You got it right. Perfect. All right, cool. Let's go away to check then. So yeah, you get 2. Okay, so that means we can go to 8. So let's look at 8. 8 is titled Work. Let me make sure you can see my paper. Yep, okay. So we have this Adam, Bethany, and Carlos own a painting company. To paint a particular house alone, Adam estimates that it would take him 4 days. Bethany estimates 5.5 days, and Carlos estimates 6 days. If these estimates are accurate, how long should it take the 3 of them to paint the house if they work together? Okay, so let's think about Adam, Bethany, and Carlos. Okay, so I'm going to do 3 different colors just to split them up. Let's break them down. So Adam is going to estimates that it would take him 4 days. So we want to figure out how much it'll complete him, or how much of the house he'll complete in X amount of time. So if we let X be equal to, in this case, days. We'll say number of days working, or in this case, actually, let me say painting. That's what they're doing. They're actually painting. How do we do a fraction that represents how much Adam gets accomplished? Well, we know he's going to be working X amount of days. And a fraction to represent the total amount he does is going to be divided by 4. So it's the amount he does, or the amount he spends on it, over the total. So if X equals 4, 4 out of 4, he'll have 1 house done, right? In 4 days, he'll have 1 house done. Bethany takes 5.5. So she'll be X over 5.5. So that's a fraction that'll give you how many houses she completes. So if I were to, this would be equal to number of houses. So each of these fractions represents the number of houses. And then Carlos is the same idea, except his is going to be X over 6. So the number of houses painted. Now the question says how long should it take 3 of them to paint the house? So one singular house. Which means we're looking at this. X divided by 4 plus X divided by 5.5 plus X divided by 6 is going to equal, well, what is it going to equal? Well, if this is the number of houses plus the number of houses plus the number of houses, that should equal a total of 1 house. That's what we're actually, at the end of the day, that's what we're looking for. We want to know if these estimates are accurate, how long should it take the 3 of them to paint the house if they work together, so a single house. And then we go through and we solve this, right? So what we want to do is get out our calculator. That's going to be useful to us. And figure out what's the least common denominator between 4, 5.5, and 6. Okay, and now to do this, this one gets a little bit tricky, Jaden, to find what this is, specifically because of that 5.5. That 5.5 can kind of throw you off a little bit. Let's see if 132 ends up working out. So that's what on my calculator I got. My least common denominator is 132. All right, so let's make our fraction. So 4 times what gives me 132? 33. So I'd have 33x. 5.5, so 132 divided by 5.5. So going to give me 24x. And then 132 divided by 6 is going to give me 22x. So to get from, so I just basically just said, okay, 4 goes into 132 how many times? 33. 5.5 goes into 132 24 times, and 6 goes into 132 22 times. Now I have all these fractions with common denominators. I can eliminate the denominators. So I have 33 plus 24 plus 22 gives me 79x equals 132. Okay, remember, x is the number of days working. So we want to divide that. So we get x equals 132 divided by 79. And so, Jane, what we're looking at is, okay, this is our number. So them combined is going to take them a total of 132 divided by 79 days. we kind of want to think about this. That's okay. I mean, that's fine. That's an answer. It's, it works. We could also, even better, is we can make this into a mixed number, which ends up being 1 2/3. It's not a huge deal. Like, I'll accept either answer. Either one of these answers I'll accept, as long as you have that unit. Make sure you put the days, right? The reason why I'll accept either is because we could translate this to hours. It's just not going to be like a clean answer. Like, we could say it's going to take them 1 day and 16 hours is what it is. 1 day and 16 hours, right? So that could be another answer. 1 day and 16 hours. So how long should it take the three of them paint it? A day and 16 hours. Is this a reasonable answer? I would say so, because if you think about it, it takes about 5 days for each of them to paint a house. So if you split that work into equally among 3 people, that's about 1 2/3. That is 1 2/3, right? So it actually, in my opinion, I think this is a very reasonable answer. If you imagine that the work gets split up completely evenly amongst the 3. So that would be your other part of the answer, and I want you to answer that however you see fit. All right, so that was number 8. You put 1. Okay, yeah. Okay, so yeah, be careful with that. I could see how you could do that. They all can. 1 multiplies into everything, so it's hard. It's easy to make that mistake. Remember, it's going to be the least common denominator, so something they all have in common, meaning something they all multiply into. 1 can be multiplied into those, but you can't multiply all of those into 1, or any of them into 1, right? So, and moral of the story, Jane, is your denominator should always be, at the very least, your biggest denominator currently. So, like, at the very least, my least common denominator could be 6. But 4 doesn't go into 6, so that's not the answer. But my point is, you'll never have 1. You'll never have 1 as the least common denominator. So if you do find you get that, you're double check your work, because it won't be correct. Any other questions on that? I know there's a couple little steps I might have skipped or glossed over, especially with like the calculating part. How I got any of that? Is there any questions? Not in this one? Okay, cool. What am I gonna have for lunch today? I don't know. Probably just a sandwich. I think I ran out of peppers, so I won't do any of those. So probably just a sandwich and cheese and some sauce and some chips. That's usually how my breakfast goes, or my lunch. How about you, Jaden? What are you having? Walleye on the grill in a pan with butter, lemon juice, and paprika, black pepper. Wow, you're going all out. I thought maybe you'd say like, oh yeah, I'm just gonna have some pasta or a sandwich or something, grilled cheese. No, man, you're having walleye on the grill. Sounds delicious, Jaden. Absolutely delicious. I know you love your fish. We have a lot of walleye from last year that we have to eat so we can catch more. Cause yeah, yeah, I feel that. If you catch too many, your freezer's gonna fill up, and you gotta eat those until you can get more. And you're probably dying to go get some more, so I understand that. I can't believe that no one else has gotten on this stream. I'm not surprised. Usually we get a calculus, but calculus took their AP test, so they're all set. They didn't have any other work this week. And algebra too, I've had a large decline in attendance, so not super surprised, Jane. You're one of the few people who show up to these. But hey, if it helps one person, it's worth it. Question 7? Yep. All right. Okay, so this says navigation. So the current in a river is 6 miles per hour. In her motorboat, Marissa can travel 12 miles upstream or 16 miles downstream in the same amount of time. What is the speed of the motorboat in still water? And then is this a reasonable answer? So I'm just going to focus on what is the speed of her motorboat in still water. Big thing we want to look at. All right, so we're given miles per hour, which is what we call a rate. We're given distance. So we need to think about what formula do we have that combines those two? And it's our distance formula. Distance equals rate times time. We're specifically looking for the speed of the motorboat in still water, but we're going to have to somehow just kind of break this down. So this equation, by the way, could be rewritten as d divided by r equals t, or d divided by t equals r. So we got 3 different ways we can express this formula, right? So we got to figure out which one we want to use, but let's just break this down into upstream and downstream. So let's start with upstream. What do we know about upstream? What do we know about Marissa traveling upstream? Okay, well, we know her distance. We know she travels 12 miles upstream. And we also know her rate. Okay, so let's start with that. If I know the distance and I have the rate, I don't know the time. So what I want to use is this equation here. I know distance, I know rate, I don't know time. So let's set this up. So distance is going to be 12 miles upstream. The rate is going to be x, which we're going to call, let me put that on the side here. X is going to be the speed of the boat. That's ultimately what we're looking for, right? X is the speed of the boat. That's what we want to find. We want to solve for X. So the question said, what is the speed of the motorboat? X is the speed of the motorboat. So whatever that speed is, if she's going upstream, that means that she's fighting the stream. All right, so that means that her speed is going to be going down by 6 because the current's going to be fighting her boat. Means it's going to slow her boat down. So whatever her speed is, the actual total speed the boat's going is going to be fighting against that current. So we say x minus 6. And that's going to be equal to t. Going downstream, it says that she goes 16 miles downstream. So distance is 16. The speed of the boat is the same, still x. We're still looking for that. But this time it's going downstream, so it's with the current, meaning the current's going to add to the total speed of the boat. So we're going to add 6. And that's going to be equal to t. So 12 divided by x minus 6 equals t upstream, and then downstream 16 divided by x plus 6 equals t. Okay, so now the question is, how do we actually find x? Well, notice, both of those equal t, and t is the same. T is total time. So like time isn't changing for each upstream and downstream. T is just the total time, meaning that 12 divided by x minus 6 has to be equal to 16 divided by x plus 6. Because if you look in the question, Jaden, it says, in her motorboat, Marissa can travel 12 miles upstream or 16 miles downstream in the same amount of time. So it has to be equal. Whatever she travels up, the time she takes to go upstream has to be equal to the time she goes downstream. So we set those equations, those distance divided by rates, equal to each other. And then we go and we solve this. So our least common denominator is the two denominators multiplied together. So I'm going to have 12 times x plus 6 equals 16 times x minus 6. Those will both be divided by our least common denominator, but we've done enough of these problems, you might be able to catch on. We can kind of ignore that. Or skip that step, I guess. Not ignore it, but we can skip that step. All right, now I go through, and I want to solve this. So you can use your calculator. 16 times negative 6 is negative 96. All right, we're going to keep going. We're going to add 96 to both sides. So I'm going to get 168. I'm going to subtract 12x. So I'm going to get 4x on that side. And x is going to be equal to 42. So my x, which is the speed of the boat, is 42 miles per hour. And that would be your final answer. Next part of the question just asks you, is this a reasonable answer? You tell me. Yeah, most definitely. I've seen other people go down rivers at 65. Yeah, yeah. I would kind of agree. Um, I think like I've been on jet skis that have gone about this speed. Probably more. I've been on jet skis probably gone more, but you can see motorboats. Yeah, I think that makes sense. And she's in some sort of body of water that's moving, so she's not like in the middle of a lake. Um, I don't think, at least. Maybe it's like I'm interpreting as she's in like some sort of waterway, like a river of sorts. So yeah, maybe I think it makes sense. I agree. If anything, I think it'd be like a little bit slow. I think she's going a little bit slower. All right. Well, hopefully that helped, Jaden. Um, I hope you have a great rest of your weekend. Hopefully you do something fun, have a good time, enjoy yourself, relax. And like I said, next week we'll do our 3 days, and that's pretty much going to be the end of it. It seems like, at least for you. It'll be the end of the streams, so won't be streaming as class. You can still hop in. I might do some streams for certain people, but we'll see. In terms of our class, I won't be teaching any new content. I won't be assigning any new. I won't be making any new assignments. So yeah, that's what we'll be at. Even if she was in Lake, she could go 100. Yeah, if she had the right boat, right? So Marissa's taking it easy. She's chilling. She's not living on the edge. All right, well, I'm going to go eat some lunch. I'm starving. I'll see you next week, Jaden. Again, hope you have a great rest of your weekend.